Okay, now, ito na. So we now move on to the topic wherein most students or students in the class would consider this topic as the most the most challenging among the OR2 topics and probably among the OR topics 1 to 3. Okay? So, for what reason, you would know later on as we discuss problems. Okay? So, whenever we reach this point, I always tell my students, lagi ito na avoid being late and avoid na mag-absent. Kasi it's possible that if you miss a lecture, an example, baka nahirapan ka may aralin yon and possibly nahirapan ka din yung sa mga susunod na problems. Okay? So try to be here as on time, or as many days as possible, but all the time. Okay? Kasi kayo ang problema. If you miss a class, this class, you can attend in the other class. Sila pwede. If they miss the other class, they could attend this class. Kayo hindi Wala kayong choice but to attend this class every time. Okay? So yun yung problema. Sino tayo mag-meeting? Hindi tayo man? At least matapos ko man lang yung concepts of next meeting, ang objective ko is to have the problems. Okay? Kailangan kong gawin lahat ng oras.
Joke kasi yung video.
Bakit?
Baba. Sila ang siya sabi. Hindi ka tayo, mabibitin na tayo sa oras.
Masyado maaga pa. Okay? So DP, okay? What is DP or what is dynamic programming? It's basically a systematic way of breaking up problems into sub-problems or components. And that's what we call the decomposition aspect of dynamic programming. Okay? So you will try to decompose the problem into several sub-problems. Okay? And eventually, recombining previous decisions to obtain, or recombining decisions done in every stages, or in every sub-problem, okay, to come up with the optimal policy for the entire problem, and that is the composition aspect of dynamic programming. So in other words, we decompose a problem, and we try to compose or integrate solutions para sa problem. So yun ang dynamic programming. Okay? So with the composition aspect, may composition aspect. Alright? So, just to give a little history, so in case you will find difficulty understanding and solving problems using DP, the person to blame is Richard Bellman. Yes, he's the one responsible for the Fort Bellman algorithm. In this case, he's not in tandem with Ford. Okay, he actually conceptualized this DP by himself. Okay, so at the time he was a researcher at Rand Corporation during the late 1940s. Doon na-develop ang dynamic programming. Okay? Kung namatay man siya, there are other mathematicians at that time who could actually probably develop the concept. Hindi ko ako kasi hindi ako buhay niyan, okay? So, he published his book on DP in 1957. Okay? And he eventually collaborated with other people like Dreyfus and Ford to develop other techniques. Yun na lang natin yung kanyang names. Okay? And the other people naman who helped develop DP are as follows. Aris, Nemhauser, Weil, Dinardo, and Dreyfus. Okay? So sila yung mga taong responsible for the development of dynamic programming. Okay? So don't fully blame the difficulty on me. Okay? I'm just trying to teach you the concept that they are developed. Okay? So Pwede sila. I have to check. Well, I don't think so. Ay, hindi siya... Ba't kailangan ba taga-Germany siya para... Nasaan ka Rand Corporation at that time? Diba nasa US to?
Pinayunikin niya yung Ayn Rand mo.
Siya?
Si Ayn Rand.
Siya ba?
Si Ayn Rand.
Bakit?
Yung pangalan Ayn Rand.
Okay. Ito yung magandang diagram that would basically describe how dynamic programming works. Okay? So, sabi natin, dynamic programming is a systematic way of breaking up problems into sub-problems. And normally, sub-problems na yan would refer to the stages. So, may stage n ka, stage n plus 1 until the last stage. Alright? And for every stage that we have, there is what we call a state of that stage. So, the state pertains to the condition to which the system is in which yung system natin, yun yung ganyang status. That is the state. Okay? Okay? And then the Sn is the state of stage n, and the state n plus 1 is the state for stage n plus 1. Okay? So again, every stage there is a state describing the status or the condition of the system at a particular stage. Alright? And given this state, okay, there are possible decisions that we could actually make. And that's the xn. Okay? And xn plus 1. So for every Sn and Xn, or meaning for every state and decision combination, there is what we call a reward. And that reward is called the Fn, or the return function. Okay? The return function basically measures how much profit that you could get with the decision given the state, or how much cost that you could incur with your decision given a state. Okay? So, dyan ka mag-formulate ng equation. Okay? Alright? Yes? State. Yes. Xn would refer to the decisions. Yes. Okay? So if we have a mathematical model class, normally the Xn is your Xi or Xij. Alright? And then your Sn could be one of your constraints or the resources in your working system. Okay? You're trying, syempre, whatever decisions that you could make depends on the resources that you have at that point. Okay? And then the F and the reward pertains to our possible value na Z, diba? Or the objective function. Now, what is this? This S asterisk Xn, which is basically equal to Sn plus 1, is what we call the transition function. Okay? The transition function will allow us to connect the state in stage 1 and the state in stage 2, and so on and so forth. Okay? So, hindi ibig sabihin na S multiplied by X by Xn yan, ha? Meaning, the Sn plus 1 is a function of our state in the previous stage and the decision done in the previous stage. Alright? Clear? And same process goes sa ating stage n plus 1 and so on and so forth. So that's basically how DP works. Okay? So if you break up mo muna siya into stages, and every stage you must have a decision to be made given the resources that you have, and you basically replicate it in the next stage until you have the last stage. Okay? Clear? Kasha? S, ito? Your state in this stage. The Sn kasi state of stage n. Ito naman isa, state of stage n plus 1 is a function of your state in the previous page and your decision in the previous page, which is stage N. Alright? Next, that's some definitions pa. So again, the Sn, Xn is the transition function which allow us to determine the input state in the next stage. Diba? Para dito yan, class. Kung ngayon, meron kang 10 units of the resource, nagamit mo ang dalawa, therefore, ilan na lang ang available sa susunod na stage? 1 na lang. Diba? So yung 10 minus 2 is the transition function. Okay? Para makarating mo yung 8 units na available sa next stage. Okay? So the F, ayan, meron tayong F, di ba kanina? The Fn. But this time meron siyang asterisk. Iba yan. The F asterisk n is basically what we call the recursive function. Kanina return function lang siya. Kasi for every pair ng state tsaka decision, there is a reward. There is a return function. Now, ang recursive function naman portrays the optimal. Okay, the optimal of among all the Fn. Okay? So, siya yung kapag may nakita kayong asterisk, di ba? Pag EOQ kayo, meron Q asterisk. The asterisk pertains to optimal. So, ganun din dito. If you have an asterisk na nakita sa F, you are pertaining to the optimal value of your rewards. Of all the rewards. Okay? So, that's why to relate it, no, we have the Fn ng isang state is basically equal to the optimal, okay, of the Fn ng state na yan plus the F asterisk of the stage na susunod, the succeeding stages or stage. Okay? So, ganun siya. Okay? So, that is our Fn at stage n. Okay? So, bakit ganyan? Merong n tapos n plus 1 dito. Kasi, when we try to solve BP, we do it using the backward pass. So, meaning we start doing or formulating the last stage. Okay? So, ganun na nangyayari in dynamic programming. Kaya minsan, kapag magsasolve ako niyan, usually, I will consume or I will use all the blackboard in front just to solve one problem. Okay? And I leave spaces in between stages. Okay? Kaya I don't require my students, I request my students to copy it later after the discussion. Okay? Unless you could provide spaces, enough spaces between stages. Wala problema. Okay? Next. This is what is good about of BP. This is what we call the principle of optimality. What is this principle which I will try to tell us? This principle of optimality will tell us states that that whatever the initial state and initial decisions are, the remaining decisions must constitute an optimal policy with regard to the state resulting from the first decision. So in other words, kung nagkataon sa unang stage ka pa lang, you weren't able to implement the best solution in that particular stage, okay? No worries. Kasi you could also end up with the best solution with respect to your mistake sa unang stage o sa previous stages. Okay? So that could be just a suboptimal, okay, compared sa pinaka-optimal talaga ng ating problem. But better in a way that nagkamali ka na sa simula, you may still recover from that mistake by trying to identify what else can you do to optimize whatever mistake that you have. Parang ganon. Okay? Parang ganon yung ginagawa niya. So, magkamali ka man ngayon, okay lang. Okay? Kaya mo pa rin makita yung best solution given your mistake. Okay? So, kaya remedyohan. Yun nga lang, it's possible na hindi na nga optimal siya sa buong buo. Na pinakamong ano yan? Parang live. Ganun ba yun? Sige. So kahit magkamali ka, kaya mo pang makamove on. Okay? And better your life, di ba? That's true. Okay? Kaya there's something bad about DP. Meron hindi maganda sa DP. And that is what we call the curse of dimensional. Sumpa. Diba? Sumpa. Okay? Curse of dimensionality. Ano ibig sabihin nun? Okay? In DP kasi that is this. The problema sa kanya, as you move from one stage to the next stage, the number of states and decisions that you can do can increase exponentially. So, halimbawa, ngayon meron ka isang state sa stage 1. But probably the next stage you may have 10 states already. And that could multiply pa in the succeeding stages. Kasi DP is what? A systematic way of enumerating all solutions. Though, systematic way nga siya, kaya nga ginagawa niya minsan, yung mga solutions na wala naman ng matutunan sa puntaan, pwedeng na-eliminate ka na. Pwedeng matanggal niya. Okay? Alright? At makikita mo yung sequence. Yun ang kagandahan sa kanya. Kahit medyo nag-enumerate ka, nakikita mo yung relationship ng bawat decisions na gagawin mo in every stage. Okay? Now, ano yung properties ng DP? Meron tayong mga properties dyan. Again, the problem can be divided into stages. Okay? Where in every stage, we have to come up with a decision. Okay? And therefore, DP is a sequence of interrelated decisions. Diba? Kasi every stage na decision ka. And these decisions must be interconnected or must be integrated sa dulo. Okay? So each state has a number of states associated with it. So it's possible that you may have more than one state in a given stage. Okay? So bibigyan tayo ng every stage isang state lang. Normally, ang unang stage natin would have one state. But as we go on, it can multiply. Okay? Next, so the state defines the set of possible conditions in which the system might be at the stage of the problem. Okay? So it will describe anong status ng system. Okay? And the state to be finite or infinite. Halimbawa, if your state pertains to your inventory level, the inventory level could be what? Infinite. Diba? It could be infinite. Okay? The effect of the policy decision at each stage is to transform the current state into a state associated with the next stage. Okay? By the way, ito mga pala is not state, this should be stage. Each stage has a number of states. Okay? So, going back, the effect of the policy decision is to transform the current state into the state associated in the next stage. So, with your decision sa stage na to, malalaman mo na kagad what would be your state in the next stage. Kasi meron ka tinatawag na transition function. Okay? Next, at each stage, a return function provides a reward. So again, for every combination ng decision and state, there is a reward. And that is our return function. Okay? The solution procedure is to design to find an optimal policy for the overall problem. Okay? So though we have one decision to be made in every stage, we will have to integrate them to come up with the decision or optimal policy for the entire problem. Okay? So yun ang gagawin natin. So, given the current state, an optimal policy for the remaining stages is independent. Okay? So in a way daw, yung state ko ngayon, okay, is more or less independent daw siya ng pwedeng gawin in the previous stages. Kumbaga parang I could solve one stage at a time. Kaya lang, eventually I have to relate them pa rin. Okay, I have to do some relationships pa rin. So, yun ang ibig sabihin niyan. So, parang independent siya as a stage, pero yung whatever decision that you have to do will have to be one, integrated eventually. Okay? And then, the process of solving it is using the backward pass. Though, pwede tayo mag-forward pass. One problem solve tayo na using forward pass. Okay? And when do we apply forward and when do we apply backward? Okay, we'll discuss that. Next, a recursive relationship that identifies the optimal policy at stage n, given the optimal policy for stage n plus 1 is available. So in other words, this one is just pertaining to what? Recursive function. So you must end up with a function that would tell us how do we get the optimal policy. Okay? And then the last, okay, by using the recursive relationship, the solution procedure moves from one stage to the next stage. Okay? So again, given the function, pwede ka na makapag-move from one point to the next point or from one stage to the next stage. Okay? So,